picture this scenario. It's late on a Tuesday night.
Oh, I already know where this is going.
Right. The harsh glow of your monitor is just burning into your retinas.
Yeah.
You currently have like 14 different browser tabs open.
Minimum. 14 is honestly conservative.
Seriously.
Yep.
One is a legacy airline. Another is a budget carrier. You've got 3 hotel booking sites. And you've probably got this complex spreadsheet going that looks less like a vacation plan and more like, I don't know, a cryptographic cipher.
Like you're trying to crack the Enigma code just to go to Florida.
Exactly. You're just trying to plan a straightforward weekend getaway. But instead of the anticipation of travel, you're locked in what feels like this asymmetrical information war. It's basically you against the airline's pricing algorithms.
It really is. It's the ultimate paradox of modern digital choice, you know?
Yeah.
You have more access to global travel data right from your living room than any travel agent had 30 years ago.
Oh, absolutely.
And yet, the actual process of finalizing a booking can feel incredibly opaque. It's like a high-stakes puzzle where the rules and the prices just keep shifting right in front of your eyes.
Yes, that is exactly it. It feels like there's this invisible barrier between us and the raw data. So for today's deep dive, we're going to dismantle that barrier.
I love it. Let's tear it down.
We've got our hands on a really comprehensive guide published by Skyscanner. This came out on March 17th, 2026. And it is essentially a masterclass designed to lift the hood on how digital travel ecosystems actually function.
It's a great source, really detailed.
It is. So our mission today isn't just to tell you how to search for a flight. I mean, you already know how to do that.
Right, anyone can type in a destination.
Exactly. Our mission is to extract the underlying mechanics of this system so you can navigate from that initial search query all the way to the boarding gate with absolute unshakable confidence. We want you to exploit these systems, basically, rather than letting them exploit you.
Which is such an essential shift in mindset. Because to set a baseline here, the anxiety you feel when booking isn't some flaw in your travel planning.
That's not.
No, not at all. It is a perfectly rational reaction to a massive, highly fragmented, and incredibly volatile global market.
That makes me feel a little better, honestly.
Yeah, this deep dive is going to act as your operational roadmap. We're going to deconstruct the back-end mechanics of how travel meta-search platforms interface with global distribution systems.
Right.
We'll talk about how you can leverage dynamic pricing models for maximum value, and critically, how to navigate the very rigid legacy technology that airlines still use.
Oh.
Which honestly catches so many seasoned travelers completely off guard.
Okay, let's unpack the architecture of the tool first.
Yeah.
Because to use a platform like Skyscanner effectively, we really have to understand what it functionally is and, just as importantly, what it isn't.
Right. Definitions matter here.
So the foundational concept here is the travel meta search engine. Now, typically my mental model for this has been like the wildly efficient personal shopper.
Okay, I like that.
Yeah, you told me you want a flight to London, and they clone themselves, sprint into 1,000 different airline offices simultaneously, look at all the prices, and report back to you.
That's a fun visual.
But looking at the technical documentation in our source material, that analogy feels a bit too, I don't know, analog. How is it actually querying all these disparate systems all at once?
Well, it's a good starting point, but let's upgrade that analogy to reflect the actual digital infrastructure.
Okay, upgrade away.
What we're really talking about is an intricate web of application programming interfaces, or APIs.
APIs, right.
Exactly. And they're communicating with global distribution systems, the GDS.
Okay, I've seen that acronym. What is the GDS exactly?
These are the massive back-end networks like Amadeus or Sabre that airlines use to manage their actual inventory.
Oh, wow, okay.
So when you hit search on a meta search engine, you aren't just sending a personal shopper into a store, you're executing a massive parallel data query. In a fraction of a second, the platform pings over 1,000 travel providers.
1,000?
Easily. Legacy carriers, budget airlines, online travel agencies. It's requesting real-time availability and pricing data across thousands of potential routing combinations.
But wait, if it's genuinely pinging over 1,000 individual databases simultaneously, why doesn't the entire system just bottleneck?
That's a great question.
I mean, if I try to load like 3 heavy websites at once, my laptop fan sounds like it's preparing for takeoff. How do they return that volume of global data in Milliseconds.
That is where the engineering gets really fascinating, actually, and it relies heavily on sophisticated data caching.
Caching, okay.
Yeah, the metasearch engine maintains this incredibly vast, constantly updating cache of global flight prices based on what millions of other users have recently searched.
Oh, so it's crowdsourced data, in a way.
Partly, yeah.
Yeah.
Combined with direct real-time API handshakes with the airlines for the absolute latest inventory. So it's a hybrid approach. It synthesizes this massive data lake to present you with a real-time snapshot of the global travel market at that exact millisecond.
Okay, so it's synthesizing the data. But here's the crucial distinction that I think completely changes how you interact with the platform.
The transaction piece.
Yes. The metasearch engine is entirely decoupled from the transaction. They do not hold the inventory, and they do not process your payment.
Precisely. This is a transparent search model, and that stands in stark contrast to the merchant model used by a lot of traditional online travel agencies, or OTAs.
Right, like the sites where you actually buy the ticket on their website.
Exactly. A traditional OTA might buy a block of seats from an airline and then resell them to you. They act as the merchant of record. Skyscanner doesn't do that at all.
They just show you what's out there.
Right. They provide the map, they aggregate the data, and they give you an incredibly granular set of filters to sift through it. You can filter by CO2 emissions, layover duration, specific airline alliances,
All the dirty details.
all of them. But once you select your itinerary, the platform essentially steps aside and redirects you to the airline or the partner agency to execute the actual booking.
So you're buying directly from the source. The metasearch is just the ultimate aggregator.
Exactly.
Which naturally brings us to the core objective for anyone listening. How do we leverage this massive aggregation engine to manipulate the pricing algorithms in our favor?
The million-dollar question. Well, to do that, we have to understand airline yield management.
Okay, yield management.
The source details an arsenal of features designed to exploit how airlines price their seats. And honestly, it requires a fundamental shift in our strategic approach to travel planning.
All right, I want to dig into this because the guide highlights a feature called Explore Everywhere.
Oh, it's a brilliant feature.
Well, let's see. The premise is you input your home airport, leave the destination blank, and the system ranks every destination on Earth by price.
Yep, that's how it works.
Now, I have to be slightly cynical here for a second.
Go for it.
Is this just a dumping ground for distressed inventory? I mean, are airlines just using this to push highly undesirable routes like a 4 a.m. Tuesday flight with 3 layovers to some secondary airport?
It is so easy to view it cynically, but it's actually a highly potent tool if you understand the underlying economics of aviation.
Okay, convince me.
Airlines operate on extremely complex dynamic pricing algorithms. Their ultimate goal is load factor. They need that plane as full as possible, but they also want to extract the maximum revenue from every single seat.
Makes sense. It's a business.
Right. So to do this, they break the cabin down into invisible fare buckets.
Okay, fare buckets. Explain how those work in practice, because I just see a seat.
Imagine the economy cabin isn't just one price, but a ladder of, say, 15 different prices.
Oh, wow.
The cheapest bucket might only have 6 seats. Once those are sold, the algorithm automatically moves to the next, slightly more expensive bucket.
Okay, I follow.
Now, because travel demand is highly asymmetrical, I mean, everyone wants to fly to Paris in June, right?
Okay.
But maybe demand for a route to Warsaw in October is lagging. An airline's algorithm might suddenly drop a large chunk of inventory into the absolute cheapest fare bucket for that Warsaw route, just to stimulate demand.
And if you're fixated solely on Paris, you completely miss the algorithmic anomaly happening with the Warsaw route.
Exactly. Explore Everywhere essentially flips the traditional, rigid travel model. Instead of you fighting the algorithm by demanding a specific route at peak demand, you let the algorithm tell you where it has excess, cheap inventory.
You're surfing the market anomalies rather than fighting the current.
That is a perfect way to put it. It lets the absolute floor price dictate your destination, which is perfect for spontaneous travelers.
That makes total sense. You're capitalizing on their need to maintain load factors on underperforming roads. But, okay, what if you aren't completely untethered?
Like you have a specific place in mind.
Yeah. What if you know you want to go to Tokyo, but you have ultimate flexibility on when you go? Like the month doesn't matter.
Then you deploy the whole month search feature. This is perhaps the most direct way to exploit those fare buckets we just talked about. Well, human beings are creatures of habit. We love to travel Friday to Sunday. Airlines know this, obviously, so their algorithms inherently price weekend departures higher.
Right, the weekend premium.
Exactly. By looking at a full 30-day macro view, you bypass those human behavioral patterns. You might clearly see that shifting your departure from a Friday to a Tuesday morning drops you into a completely different, much cheaper fare bucket.
Simply because the algorithm anticipates lower business and leisure demand on that specific Tuesday.
You got it. You are stepping out of the high-demand behavioral flow.
Okay, but let's look at the absolute worst-case scenario for flexibility.
The rigid traveler.
Yes.
Hmm.
You have to be in Chicago, you have to be there for a wedding on the 14th, you have zero flexibility on the where or the when.
That's tough, but in that scenario, you're playing a waiting game with the airline's revenue management system, which is where price alerts come in.
Oh, right, because nobody wants to sit there refreshing the page every day. Yeah.
Exactly. You don't want to manually check the route every day. You set the parameter, and the platform continuously queries the GDS in the background. The moment the airline releases a new, cheaper fare bucket, or perhaps a competitor airline drops their price, forcing a market match, the system alerts you.
So you let the servers do the relentless querying for you.
Work smarter, not harder.
All right, so we've used the macro view, we've bypassed the weekend algorithms, and we've secured an incredible fare. We're ready to transition from searching to actually executing the transaction.
The moment of truth.
Which brings us to the moment of maximum friction and maximum paranoia for the user.
The handoff. The point where the money actually moves.
Yes, and we need to address the elephant in the digital room, the ultimate travel booking conspiracy theory.
Oh, boy. I know what this is.
I read this section in our source material on privacy and cookies, and I want to really push you on this because we have all experienced this scenario.
Everyone has a story about this.
Right. You search for a flight. It says $400. You wait 20 minutes to text your partner to confirm. You come back, you hit refresh, and the exact same flight is now $450.
Yep.
The immediate visceral reaction is, the cookie monster got me.
The cookie monster.
Right. The website tracked my IP address, they saw my intent, and they artificially inflated the price to create false urgency and force me to panic buy.
It is the single most pervasive myth in the digital travel sphere. And from a psychological standpoint, it makes perfect sense why we believe it.
It feels so real.
It does. We're hardwired to assign causality to sequential events. I searched, the price went up, therefore my search caused the price to go up.
Exactly.
But if we look at the strict data privacy limits detailed in the source, and more importantly, how airline inventory actually functions, the conspiracy completely falls apart.
Okay, I am a skeptic. Dismantle it for me.
I'll try.
If they aren't using cookies to profile my intent and squeeze me for $50, what exactly is happening under the hood when that price jumps?
It comes back to the GDS and those invisible fare buckets we discussed. The guide is unequivocal on this. Cookies on a platform like Skyscanner are used for basic site functionality and retaining your search parameters locally.
So it remembers I want to go to Tokyo.
Right. But they are never used to manipulate pricing or simulate artificial demand. When you see that price jump from 400 to 450, you are experiencing the brutal reality of a global live market ecosystem.
Meaning someone else beat me to it.
Exactly. Or, more accurately, the entire global market beat you to it.
Wow.
Remember that $400 fare wasn't the price of the whole plane. It was the price of the last two seats in the, let's say, K-class fare bucket.
Okay.
While you were texting your partner for 20 minutes, a corporate travel agent in Frankfurt booked a multi-leg journey for a client that happened to include your exact flight. They bought the last K-class seat.
Oh, I see.
The airline's algorithm instantly, automatically closed that bucket and opened the next one up. The M-class bucket, which is priced at $450.
So it's not a localized conspiracy against my IP address. It's literally just the global inventory depleting in real time.
Precisely. And there's another technical factor here called ghost availability.
Ghost availability, that sounds spooky.
It's just technical latency. Remember we discussed how metasearch engines use caching to prevent the system from crashing?
Yeah, the data lake.
Right. Sometimes that $400 price you initially saw was a cached price from 10 minutes ago. When you hit refresh, the platform executed a fresh, hard ping to the airline's API, and the airline system replied, "Actually, that bucket emptied 5 minutes ago. The live price is now $450.
Ah, so it feels like manipulation, but it is simply the latency between a cached database and a highly volatile live inventory system.
Exactly. The cookies aren't out to get you. The market is just moving faster than you are.
Wow. Okay, understanding the latency in the fare buckets actually removes a lot of the anxiety. It's just a live market, like trading stocks.
Very much like that.
So we've navigated the pricing algorithms, we understand the cache delays, and we have our transparent search engine handing us off to the partner site to buy the ticket.
The handoff.
But that handoff is exactly where the sleek, modern digital facade ends, and we hit the brutal, unforgiving reality of legacy airline infrastructure.
Which is what we call the danger zone.
The danger zone.
Yes. The source material spends a significant amount of time highlighting user errors, and it's vital to understand why these errors are so catastrophic.
Right, because we are so used to the flexibility of modern tech. If I make a typo in an email address, my app usually flags it.
Sure.
If I mistype a shipping address, I can usually log in and change it later. But booking a flight is completely different. You're interacting with systems built in the 1970s.
Exactly. You are generating a PNR, a passenger name record.
A PNR.
Yes. This is a secure legacy format that lives in the global distribution system. And because of international security protocols, specifically the Advanced Passenger Information System, or API, that PNR is deeply rigid.
Rigid how?
A perfectly smooth, algorithmically optimized booking can instantly turn into an airport nightmare because of a single mismatched keystroke.
Okay, let's talk about the name mismatch, because the guide highlights this as a critical failure point. It's not just about the airline being pedantic, is it?
Not at all. It is a strict security mandate. The name on your PNR must identically match the machine-readable zone on your government-issued ID or passport.
Identically.
Identically. If your passport says Alexander and you book using your autofill on your phone, which defaults to Alex,
Oh, no?
you have created a severe friction point. When you scan your passport at the kiosk, the API handshake between the airline system and the border security database fails. The system throws an error.
And then what?
You're entirely at the mercy of a gate agent's discretion, or more likely, you were denied boarding.
You literally get grounded by your own autofill. That is terrifying.
It happens every single day.
And it's not just names. It's the chronological mismatch. The midnight flight trap.
Oh, this is a classic vulnerability when booking across time zones.
Explain this one, because I've almost fallen for it.
If a flight departs Tokyo at 12:30 a.m. on a Wednesday, a massive percentage of travelers intuitively map that to their Tuesday night timeline.
Right, because you're staying up late Tuesday night.
Exactly. So they show up at the airport on Wednesday night, roughly 23 hours after their plane has departed.
Oh, my God.
When you're querying thousands of global options, you have to be hyper-vigilant about the dateline crosses and the AM/PM markers because the system assumes you know exactly what local time you are dealing with.
It will not hold your hand.
It absolutely will not.
And then there's the ultimate pre-flight disaster, which has nothing to do with the ticket itself, but with the documentation required to execute the ticket. The 6-month rule.
Ah, yes. This is the invisible tripwire that catches thousands of travelers.
Okay, break it down for us.
You find the perfect fare, you secure the booking with your passport details, and you assume you're clear. But many countries mandate that your passport must be valid for a minimum of 6 months beyond your planned date of departure from their country.
Okay, wait. So your passport is totally valid today?
Yes.
It's valid the day you land in the country?
Yes.
But you still get rejected?
Yes. Because if it expires 4 months after your trip, you violate their entry visa requirements.
That is wild.
And here's why the airlines are so ruthless about this. If an airline transports a passenger to a country where they are denied entry due to improper documentation, the airline is heavily fined by that government.
Really? The airline pays the fine?
Yes, and they are forced to fly the passenger back at their own expense.
Oh, wow.
Therefore, their back-end systems are designed to preemptively block you from ever getting on the plane.
They will deny you boarding just to save themselves the fine.
Exactly.
Which brings us to the final piece of the puzzle, the confirmation. Because the metasearch engine isn't the merchant of record, they don't issue the ticket.
Right. Your transaction is with the partner airline, or the OTA. The source emphasizes that you must verify receipt of a ticket number.
Like an email confirmation.
Not just a payment receipt, but a 13-digit e-ticket number. If you haven't received that from the partner within 24 hours, the PNR generation may have failed, or there was an API timeout during the payment gateway process.
So what do you do?
You must proactively follow up with the merchant of record, because without that 13-digit number, you do not have a seat on that plane.
It doesn't matter if your credit card was charged?
Nope. No 13 digits, no flight.
So, synthesizing all of this for you, the listener, we've journeyed far beyond the initial overwhelm of 14 browser tabs.
We've covered a lot of
We
ground.
really have.
Yeah.
You now understand the architecture. You know that metasearch platforms are executing massive parallel API queries across global distribution systems and maintaining complex data caches to give you a real-time market snapshot without, crashing the internet.
Right.
You understand that features like Explore Everywhere aren't just gimmicks. They are tactical tools to exploit the temporal troughs in airline yield management algorithms.
Surfing the anomalies.
Exactly. You know that jumping prices are a result of global fare bucket depletion and ghost availability, not some localized cookie conspiracy designed to squeeze your wallet.
The cookie monster is dead.
The cookie monster is dead. And critically, you know that the friction point between these sleek modern search engines and their rigid 1970s legacy P&R systems requires absolute surgical precision on your end regarding names, dates, and documentation.
It really is a fascinating intersection of massive algorithmic power and hyper-specific personal responsibility.
That's a great way to phrase it.
You're leveraging supercomputers to find the most mathematically efficient route across the planet, but you still have to manually ensure the letters on the screen match the physical book in your pocket.
Which honestly leads to a really interesting thought about where this is all heading.
The future of all this.
Yeah, because we spent this entire deep dive talking about how to optimize our human interaction with these systems. But looking at the trajectory of the tech we've discussed today, how long until we aren't the ones interacting with it at all?
That is the ultimate frontier. We are rapidly approaching the era of autonomous AI travel agents.
Right. Imagine an AI agent that doesn't just aggregate the data like a meta search engine, but actually executes the whole strategy we just discussed.
It would do it all for you.
Yeah, you just tell your AI, I want to go to Europe in the fall, budget is $800, and the AI continuously queries the APIs, predicts the fare bucket drops based on historical yield management data, perfectly inputs your PNR details, avoiding any human typo errors, and just hands you the finalized 13-digit e-ticket.
It completely eliminates the user error and the danger zone we just discussed. The AI handles the latency, the caching, the PNR rigidities perfectly.
Sounds amazing.
It does, but it raises a deeply provocative question about the nature of travel itself.
How so?
Well, if we outsource the friction of planning entirely to a hyper-efficient algorithm, do we lose the serendipity of the process?
Oh, I see what you mean.
Part of the joy of using a tool like Explore Everywhere is the human friction. It's that sudden realization that you could afford to go to a city you've never even considered. An AI agent optimizing strictly for cost and your past behavioral data might just trap you in a predictable algorithmic bubble.
Might send you to the same type of destination over and over because it's quote-unquote efficient.
Exactly. We eliminate the stress, but we also eliminate the happy accidents. It becomes a purely logistical transaction rather than an exploration. We finally beat the algorithms, only to hand the keys entirely over to them.
It's the ultimate trade-off between absolute digital efficiency and human spontaneity. Something to carefully consider the next time you were staring at that search bar, deciding where in the world you want to go.
A brilliant thing to ponder as we watch this technology evolve.
Absolutely. Well, stay curious, keep an eye on those fare buckets, and let the meta search do the heavy lifting. Until next time.